We are looking at a 5,000 share order.
Hello, and welcome back to another episode of Google Cloud Live. I'm Vlad Kolesnikov, Developer Relations Engineer at Google Cloud. And today I'm here with Leonid Yankulin. Leonid.
Hi. Hello, Vlad. Thank you. I'm Leonid. I'm a developer advocate at Google Cloud, working with Vlad in the same team. I specialize on AI workload security and observability, but today I will be talking to you about data and agent evaluation. Back
Agent
to you, Vlad.
evaluation. We say from vibe checks to data driven evaluations. What do you think vibe checks are? How would you describe them?
Thank you. And let me switch to the slides for a moment. So when we speak about vibe evaluation, or before that, I want to address the question, why do we need to evaluate AI agents in the first place? Today perception is that AI is smart enough to do the work. And so why do we need to test AI? The main problem is that today people don't believe AI like they did in the beginning when it just came. I believe that our audience also don't think that AI is perfect and never makes mistakes. So when we speak about vibe check, we usually speak about testings that we do manually. We run our application, our agent. We ask a few questions by manually typing or feeding the information to the agent. And then depending what kind of answers we get, if it is good, we assume that everything is works. And if they are bad, we return back to the code or whatever configuration of the agent we work with, and we try to adjust some settings, configurations, prompts, and so on.
So basically, it's kind of similar to testing normal software. And, if you just write a regular deterministic software, you can make a change and then you can just like run your application or your service, try a few things like your happy paths, see that they work, and you just like push it to production. And we know that it often breaks. With I guess, at generative AI these days, it's even worse because the AI is like generative AI is fundamentally not deterministic. So even when
True.
we try something and it works at the moment, it may not work next time. So kind of,
It is true.
yeah. So basically, the importance of testing or checking it increases. And why don't we just like test it manually, right? Like we do with the regular software. Remember, like in the past, we had all those testers, and then we end up having automated tests, and then people started talking about unit tests. So that's kind of that this is all applies to traditional software. What about AI these days?
So I have news for you. We still have these people. We still have QA departments that do a lot of tests manually, like running by themselves. And to be honest, as a developer advocate, I often do this kind of a test by running user journeys on our products that yet to be released. However, you are completely right. The main reason that manual testing doesn't work well is actually twofold. First, and it is very trivial, to test all possible scenarios that we know or expect to work, like golden paths or critical user journeys, isn't effective when we speak about application or service at scale, because there are too many, and each time when we introduce a change or like submit a PR request or something like this, to run it by people, it is just very, very slow. Another reason for this is that when people run it, again, I don't know your experience with QA teams. In my previous workplaces, QA teams were filing some test reports besides the bugs that they found, describing what they actually test. They had test plan documents that they checked. I did this test, did that test. But in many cases, still a lot of stuff remains behind the scene. And so all these test sessions kind of ephemeral. You can't like track what actually was done. You can't compare against previous executions and success. And this is why we actually moved from focus on manual tests by the teams to more automated approach.
I see. I see. So now, if we look at this testing software that we do, or evaluation, right? With AI and software is similar, but with generative AI, it's kind of a common thing, and it comes from traditional machine learning. We do evaluate stuff during development, right? During the experimentation stage, and we change our prompts, and then we see whether agents behave better or worse. So now, what's the difference between this experimentation and really the evaluation in the form of where traditional unit tests are used?
So as we said, in general, the manual testing, especially for AI, it is much more, I would say, relevant. Manual testing for AI phase, when we try to tweak our configuration for AI, we don't actually code AI, right? We don't modify code for the model in
No, we
general.
still can. We still can, right?
We can, but when I speak about software developers, not data engineers, not AI scientists, we adjust some configuration, like there is a parameter called temperature, which describes how much we allow to the model to experiment or go to some discovery phase. And there are other things like system instructions, prompts, additional information that we can plug to the system, or some logic provided with the agent configuration. So this is kind of the phase that we can call discovery, when we experiment. And it is hard to algorithmize experiments. So it is naturally have a creative and open-ending approach, which makes sense to do manually, to have a person doing it versus the agent. On another side, we have our CI/CD process that have to be rigid and repetitive. And
Oh
for
yeah.
this
So
process,
yeah, just
yeah, go.
for the audience, like when we say CI/CD, we mean like continuous integration
Ah,
and continuous
yes,
deployment, as far as I remember, right? And this
yes,
is where,
correct.
yeah, this is where effectively our software, on this case, our agent, is sort of like done or almost done, right? It's in the process of final tweaks, or it's in the process of being continuously improved, because this is what we do. We continuously improve our software. We test new models. We do little tweaks with our prompts or systems instruction, etc., etc. Right? So, and I.
I would
Mhm.
say yes and no. actually, because when we say agent, today this has a certain ambiguity because the agent includes some interaction with the model. I can simply change the model I use and start using a different model, which can completely change the behavior of the overall application. But I can also go and add some tools, some instruments that the model can invoke through some thinking process. The model can be made aware by the agent that it can use some tools. And these tools essentially implemented as simple functions as in the body of the same agent, part of the same application, or it can be implemented as some remote service that the agent can call based on the request from the model. And I can change these functions simply. And by this, I again can influence how things work. So sometimes when we commit the change, we make the change, we don't know how it will affect overall work of the agent, especially as we mentioned, due to unpredictability and lack of determinism of the model. Additionally, I want to jump a bit aside and speak about DevOps work that includes testing of the whole system. Some integration testing, system testing, the terminology can vary, but it means that maybe we make a change to a completely different component of the overall application, not the agent itself, that still can affect one way or another how the agent behave, and we still want to test it. As a result, we want on any change that gets submitted to our source management system, integrate the testing of the agent, and this testing can be done manually, or better say, it can be done manually, but it then inherits the problems that I previously mentioned: very slow, ephemeral, without tracking, without comparison, and again, the testing is kind of hard to do because it requires quite a lot repetitive operation, and we need it to be rigid.
So essentially, what I'm kind of seeing, and when I look at this defense mode of continuous evaluation, is it's very similar to a combination of unit tests and integration tests. We effectively have a set of happy paths, like right the and I will oversimplify the prompt and the responses, whether it's individual agent in a multi-agent system, or it's the whole multi-agent system that gives you a response after going through a number of iterations internally. We want those happy paths to work despite us making some changes, right?
It is very good point. I saw starting 2024 when the AI emerged as a new way to implement applications, that there were many discussions about how we do it with AI, how do we do it a new way. But in my personal opinion, it is the same old way. We have the same unit tests, we have the same methodology. We just adjust certain implementations to the fact that AI-driven workloads, they behave differently. To your point, the main challenge to implement the standard success path is the same problem that it is not always easy to do with AI because AI is probabilistic. I believe we will repeat this mantra along the whole broadcast as a reason for all things that we do or we show. So correctness verifications in with AI requires what we call semantic judgment, because AI doesn't essentially returns 1 for success or 0 for fail. It can return a variety of information even when we instruct it to return information in some structured form instead of having it return in the free text.
It's good that you mentioned that, because now we can start talking about like the ways that we test AI, right? So what are like, obviously we have traditional software where we can just like run some code and measure, the results, and it's usually remembering that how we write unit tests, or that some method was called, or the return value contains this string, or this value equals 1 to 3. What's the difference with AI, and what's the approach to do it in general, and then we can talk about doing it at scale.
Okay, so I actually thinking where will be the best way to start. We have put 2 pairs of categories, probably the best way to describe it. I want actually to start with with code-based versus model-based categories with graders. Because it kind of continues the previous discussion about unit testing with the old style and new style. So the interesting point is that despite what I mentioned previously, that AI doesn't return very deterministic responses, it is still possible in some cases implement the standard verification mechanism that follows a precise and deterministic path, because some qualities of the AI response still can be enforced. For example, we can enforce AI model to return all responses in JSON according to some data model.
Oh yeah, that's structured output, right? So we can force it. We want to make sure that that's still the case, right?
True. And then we can define a code-based grader or validation process that comes and check if the JSON structure match the models that we actually asked. Because again, model behavior is not deterministic. So model for some reason can decide that for this particular request, it makes sense to create a additional field to the JSON because will be very useful according to the AI. And for us,
or the developer decides to change the model because some model works faster, but it's not that great with structured output, and then we end up with garbage.
Someone could decide that they will change it without properly communicated along the all implementation logic. So we can still use code-based deterministic validations. However, for the rest of the stuff, like if we actually need to analyze the content returned by the model, we need to use so-called model-based graders, or they are also often referenced as LLM as a judge, which use a strong AI model to evaluate the information according to some criteria that we define as part of the code. Now, the important point here is that this strong model it's not a requirement, I believe, but it is very strong recommendation. It should be stronger. Okay, I repeat strong too many times, but anyway, it should be stronger than the model used by the agent. So using the example with Gemini, we have Gemini 3 Flash model, very good model with multiple levels of reasoning, supporting multimodality inputs. And we have a Gemini 3 Pro model, Right now they are 3.5, I believe, specifically. But the Pro model is the model with much larger context and a much, I don't know how the better define it, more depth probably. I'm not an engineer, so if I talk gibberish at the moment, I beg your pardon. I only know that the Pro model is much stronger than the Flash. This is my level
Yeah,
of expertise.
it is true. I mean, in general, it's fine sometimes, especially like when you do this at scale, to use not necessarily the Pro versions. What's important is that the model, I would say, the checks are not part of the execution flow themselves, because right, if you just take your usual LLM, ask it to do something, and then at the end, or you can even add make no mistakes in the prompt, right? You still need another sort of like independent entity to look at it and tell whether something makes sense or not in the setup that excuse me, in the setup that we have in terms of the system instructions and the input that model received and then the output.
Yeah. Thank you.
So now,
You are right.
yeah, you want to talk about reference based and reference free
Yes.
metrics?
So I mentioned criteria in the previous when we spoke about when we spoke about graders. I mentioned that for model it uses criteria. So when we define criteria, we can define them in such a way that the test references something like a ground truth or a golden data set when it evaluates the criteria, or it can use a reference-free criteria, which is some kind of universal. As an example, consider that we do expect, for example, and this criteria, this metrics can be used with any types of the graders, obviously. So you can consider using, for example, for the code-based grader, we can use a deterministic validation that the JSON that the model returns is well formed. So the syntax of the format is preserved, and the parser will be able to process it. And vice versa for the model-based, we can provide the reference that includes some specific information that should be mentioned. Examples, it can be information about I don't know about chemical elements or whatever.
Yeah,
Same
just
goes
to
for
give
the
a few
reference free.
examples. So the reference-based metrics is essentially when we sort of like have the right response, right? If I ask the agent about, and this is the example that we're going to use, like a history of Rome, right? I may have a text with the expected response, and then the this grader will look at the question and at the expected answer, and then they compare it, right? And I guess the reason we use metrics and not just like a straight comparison is because usually, like due to this non-deterministic nature, like you said, we're going to mention it a lot of times, they would normally never be the same. So we need to compare them somehow and then establish this sort of similarity metrics, like, oh, how similar the answer is, right? That's sort of like one thing. Another thing, like with the tools, again, like we have this prompt, and then we have some expectation that if we ask a question, the tools will be called, and there's going to be parameters, and there's going to be results of the tools. And again, they're not always the same. They still do the job, they still do the task, and from anyone's point of view, it's right. It's not going to be 100% right. That's why, like in traditional machine learning, we introduce this evaluation metrics, and then we decide for each metric, and like what's going to be the value that we consider okay. Is it 90%? Is it 75% that is right? And once it's not right, we can say no, this change actually broke the agent. Or if we pass, then we say okay, fine, we go. With the reference free metrics, we essentially ask the agent to verify the answer without having the right answer, right? And that example that you gave with whether it's JSON or not, like valid JSON, right? We don't need to have a reference. We just need to see if it's valid JSON, or if it matches a certain schema, right? We don't need the right answer. We just need to check whether it's in the correct form. And we have different ways to use this reference-free metrics with something that is not necessarily as rigid as JSON, right? We can see if the text, for example, is fully grounded in the data that agent acquired through sub-agents or through some tools, right? We can evaluate the grounding, whether it's with some traditional and like NLP metrics such as BLUE, right? When we just like compare words and allow it to be different but not too much, or we can use an LLM grader and ask it to see if there are any facts in the text in the result that are not grounded in the source data. And because the models, they may be very creative, they may use and they do use all the time data that they were trained on, which may not necessarily be true, right? And especially if they see a familiar topic, they may enhance the answer with their own knowledge that was not necessarily given them during this inference process inside the engine. And again, like I said, the knowledge may not be true, and that applies to a lot of things, starting from, like, I don't know, soccer or football player stats, to some laws and regulations, or tax code, etc. It changes all the time, and every model is sort of frozen in time with the data that it was trained on. So we need to enhance it with additional tools and data sources, and use all these techniques, agentic RAG, retrieval augmented generation, etc., etc. So, and we need to be able to check whether what we did, like those changes, whether they broke this flow and the model started producing, models started being too creative, right?
Yes, Vlad, I am afraid we start losing the audience with all the theory. What do you
Yeah,
say we will
let's
move
move
to
to the
the
meat,
less
right?
implementation part? So, would you share with us how we are going to demonstrate all this
Yeah, certainly.
process of testing?
First of all, we actually have a code lab that people can try themselves. So everything that we show today, you can try yourself. And if we switch from the slides to the code lab that I'm currently sharing, it will be shared as a link, as a resource for this broadcast. But effectively, everything that we're going to talk about is in this code lab, and there is a repo for this code lab that you can clone. You can clone the kind of the final lab, or you can clone the starter branch and go through the lab yourself. And yeah, we talk about the evaluation. We talk about deploying those agents and testing them as part of the continuous integration and deployment process. But I think we can just switch to our agent and show it in action, and as well as basically tell people what that agent does and why and why does it this way, right?
Yeah, just one note that I wanted to add. We are not going to run this lab right now. We did a quick shortcut to save time, and we enrolled and prepared all the setup steps up to probably up to step 7. So we will go and review the code, how it implements and how it match versus the short theory introduction that we did. You can later watch us again if you enjoyed that, seeing it, or you can read through some information in the steps.
Okay, I'm going to share my anti-gravity.
I believe, Vlad, that anti-gravity is your platform of choice, but it is not necessary to implement this, right?
It is not.
Just checking.
But this is where I code anti-gravity IDE. So let's talk about the agent first, and the structure of the project in general. So this is a multi-agent system that has multiple agent, and that also has the orchestrator agent that kind of, babysits those little agents. And if we look at the code, let me actually look at the orchestrator code. That it's better to show than tell about it, right? So the orchestrator, it's effectively one of those deterministic workflows that agent development kit supports. Oh, that is important to mention. We obviously developed our agent using agent development kit. So it's a sequential agent that has 2 sub-agents, and by the name of this class, you can tell they run one after the other. We have a research loop that kind of looks for data, evaluates whether it's good data, and may like repeat the process of discovery. And we have the content builder that builds the content. What kind of content? Our whole system is actually an education course builder. So the user specifies the topic that they want to learn. I don't know, linear algebra. And our agentic system looks for the information about this topic on Wikipedia, right? Using Wikipedia search and the information that it has. And then
a tool,
yeah,
right?
it's a tool, right? And that's what researcher does in our loop engine, right? And then we have judge that judges whether what researcher found is sufficient for for building an like a plan of the education course. And then we have an additional lethal agent that just checks for escalation. Like when the agent says it's good, like we can break the loop and finally go to building the content. So
yeah,
let me run.
Vlad, effectively, it looks like we use this LLM as a judge pattern for our own benefit in this application. It is not related to the testing, but it's just used for us to validate the results, very similar to how we are going to evaluate, right?
Yeah. And I want to just demonstrate the agent in action. And for that, I have to stop sharing again and share the creator, the course creator. So let's say I wanna learn about history of Rome. Right, that's a little web app that is built on top of the agent. So essentially, as you can see, internally it starts from researching the topic, then it will go to fact checking, and then it will go to writing the actual course. The fact checking is really the judging. It doesn't necessarily checks the fact. It checks whether this information that we are going to build the course on is comprehensive enough. So it checks for a few things. So while it's doing its work, let's look at those individual agents, and we start from the researcher because
maybe we want to check what they do. what we want to test actually, instead of exploring the application code and look on the code from the perspective what we actually validate. What do you think?
Yeah, and that's why we start with the researcher, because that's one of the agents that we're gonna test, right? So the researcher agent, it's a very relatively simple LLM agent with certain instructions, with the Wikipedia search tool that we give it, right? And effectively, when we enter this, like, history of from prompt, the agent goes ask Wikipedia for this topic, and then almost like returns almost whatever the Wikipedia search um, returned to it. It's a very simple thing, although we still need to make sure that, for example, it doesn't hallucinate with additional information that is not necessarily correct. If we look at the judge, right, which we're not going to evaluate separately, we can see that it evaluates whether it's like it's high quality information, and if facts are supported by data, et cetera, et cetera. And then finally, for the content builder, it gets the information that we received and builds the course in a certain format. That's what we do, and when we test agent as a whole, we basically test the result that the content builder provides us, right? And we in the application, this web app that we see, we will see the result of the content builder agent. They're still working, by the way. So now, how are we going to test this? For this lab, we build a set of helpers, I would say, right? And if we think about different approaches and tools that we can use for testing agents, we obviously need to talk about frameworks and systems. And fortunately, in Google Cloud, we have a Gemini Enterprise Agent Platform, which we use Gemini through. But it also has GenAI evaluation service, and GenAI evaluation service consists of the SDK and the service in cloud, right? The SDK helps you set everything up, kind of wire your agent, and even test things locally if you want. And with the GenAI evaluation service in the agent platform, you can run those tests at scale. Today, we're going to run things locally just to make it faster, because in our case, whether we test researcher, and by the way, this is our test data and that I prepared, or we test the orchestrator as a whole, we have very little data, so we can sort of test it locally. And when we test researcher, you can see that we're going to use a few reference-based metrics because we have references for the answers, as well for the tool calls, for example. And for the orchestrator, you might have noticed already that I only have a prompt, and that's it, right? I don't know the right answer. It's just it. So we will
Vlad,
see. Yes.
can I interrupt you for a second?
Of course.
I probably missed it. Where do we use these JSON files? How do we feed them into the system?
We feed them through the GenAI evaluation SDK that agent platform folks built for us. And in the code, you can see there's a shared folder. There's this evaluate.py that essentially reads a JSON file and calls all the SDK methods such as like creating evaluation run to actually submit the data to the evaluation service or the evaluation SDK. So effectively, what we
Sorry for interrupting you again. So
yeah,
just help me to understand where the evaluation actually runs, like each step of it. What do we actually run on the agent platform?
Oh, that's a great question. So first, since our agent, especially now, it runs locally on my machine, um, um, or it can run in our case, which we provide the code for in Cloud Run. First step that we do, we run the agent inference, right? So we effectively call the agent ourselves in this run parallel inference function.
So our
And
test does this execution, right?
yeah, it's either runs on my machine or it runs in, I don't know, in Cloud Build, whatever CI/CD system you have, you actually call the agent, right? For real. And it's not the GenAI evaluation service that runs your agent or calls your agent. Because you need answers from the agent. The ones that agent actually provides when you give it the prompts. And the beauty of this is that you run your agents in kind of real environment. It's either real environment, meaning it's not like with unit tests when you call functions individually and you create a bunch of mocks, etc. No, like you call LLMs and LLMs produce answers, right? And it's all for real. It's not some mock things that we invent. It's all for real. We collect those that data set and mix it with our test data. Remember, the test data is this little JSONs, right? So it's prompt, it's reference answer, and then reference trajectory, which is tool trajectory that we expect for this prompt, right? And we do this for real. Once we have this data set with prompt, reference answer, if we have it, and then the real answer, we can submit this to the evaluation service or evaluation SDK if we do it locally, and just ask to, make those judgments, make those runs with custom metrics, etc. And then we effectively can produce the evaluation metrics and then decide whether the values of those metrics are high enough to, to sort of pass the test, right? Hopefully I answered your question.
Yeah, thank you.
Yeah, meanwhile, our agent finished the course. I'll briefly show you how it looks. Here we go. So yeah, I asked for a history of ROM. It got a bunch of info from Wikipedia, and then it built a plan for, for in 10 modules to create a course of history of ROM. And this is not the whole course, obviously, right? It's just a very detailed plan that you can use to create. You can create another agent that actually builds every single module, and this way you create the whole course. All right, switching back to our IDE. A lot of back and forth, but that's what we do as developers, right?
Hopefully we do it less with AI.
So yeah, we have our agent running already because we tried it with the website. Let's actually run the evaluation. And if we look at our individual evaluation code, right, the evaluate agent, you can see that we evaluate two agents. Like there is a piece that when we evaluate the researcher, which is the very first agent that is being invoked, I would say very first LLM agent that is being invoked by the orchestrator, because orchestrator is essentially like a deterministic workflow inside ADK, right? And we try different metrics with this. Some of them are reference-based. For example, response match. It evaluates whether the response of the agent is close enough to what we use as a reference answer. Some of them is reference-free, such as response quality. It just assesses the quality of the response, like in English language, whether it's good or not. Same with tool use quality, right? It assesses whether the tool are used appropriately. And there are some custom metrics that I created to calculate trajectory precision, trajectory recall. This is for tools, right? Whether our reference tool trajectories sort of like reflect the real trajectories that we have. That's for the researcher. And then,
Vlad,
yeah,
can you elaborate to people like myself who think they understand what trajectory means in this context, but not entirely sure? It is
tool
obviously
trajectory is essentially a sequence of tool calls, like whether you call certain tools in certain order, right? The arguments of those tools and the results of those tools, especially if the tools are like entirely deterministic, right? That's what and trajectory is. Like when we say about tool trajectory, it's essentially the sequence. And then the way you can measure it is different. Like if you don't care about the order, then you may say, oh, I want to evaluate the trajectory. I want to have these tool calls in any order, right? Or
Mhm.
I want to make sure that this tool call wasn't there. I don't care whether there were other tool calls or not. So you can combine this.
Understand. And these
Um,
are custom metrics. The platform doesn't provide this specific
yeah, I
type
literally wrote
rubrics.
this
Sorry,
code.
not metrics, rubrics.
Yeah.
Yes. Okay.
And then we also have the orchestrator where in this case, we just check for hallucination, and the hallucination grader, right? The grader that runs as part of the GenAI evaluation platform. It checks whether the response is grounded or there are pieces that are completely made up and they're not actually in this initial data that was returned, in our case, by Wikipedia. So let's run the evaluation. Like I said, we're going to run everything locally. It's going to call our agent that runs localhost, surprise, surprise, runs on my machine. And it's going to take some time. And while it's running, we actually can talk about different kind of rubrics, right? We say like rubric metric. What is even rubric metric?
Good
Let's
idea.
call it, yeah. And the rubrics, it's essentially like a prompt for judges, I would say. That's what I like to call it. Maybe it's not the most precise definition, but that's how kind of I like to call it. It's prompts for judges. And the funny thing that there are static rubrics and there are dynamic rubrics. What's the difference between them? So the static rubrics is when we effectively, I know hallucination is a great example. When we tell to the judge, like, oh, here's the prompt, here's the result, see if, and here's the intermediate steps such as calling different tools, etc. And we want to see if all these data is grounded, like please LLM go and check if every sentence or every paragraph is actually grounded in this initial data so the model doesn't hallucinate. The dynamic rubrics is different. We effectively look at the question, look at the description of the agent, and then we tell another LLM generate the prompt for the judge to evaluate this result. So basically, it happens that the prompt for the judge, essentially the things that this judge is going to check for, depends on the question. And I'll give you an example. Let's
Okay.
say I'm running like an online store and I sell headphones, right? And I ask the agent how much are these kind of headphones, earbuds, how much are earbuds. So in this case, when the system, the evaluation service sees the question, and when I say that I want to use a dynamic rubric, it's gonna form the judge question in the form check if the answer contains price for the headphones or the earbuds, right? That's how this dynamic prompt is going to be formed. And for every, like, let's look at the researcher. For every question that I have, this prompt for the judge is going to be different because the judge will be checking whether the question is actually has answer for the answer is going to have the data that fulfills the question. That's the dynamic rubric.
So let me understand. We previously mentioned the problem of the probabilism and lack of determinism when models involved. If this rubric generates the specific prompt or specific response each time, does it mean that on each execution it will be different?
Pretty much.
And then how do we guarantee the different runs of the same of the test with the same rubric will provide us with a similar level of validation, if you wish? How does it help us if it is not deterministic?
That's a great question. We obviously cannot guarantee. Nothing in AI world is guaranteed.
Okay.
But the good thing is that we can do things at scale. So instead of guaranteeing something, we just do something a lot of times, right? And if you read the documentation, for example, about these different metrics that we use, different rubrics, you will see that underneath that question that we ask judge to answer is actually asked many times, right? And then we sort of like there's this.
So each prompt,
Yeah.
each
Yeah.
prompt doesn't mean like compared to the conventional software testing when we have each test and we have a collection of inputs, for example, that we can match to the collection of prompts in our JSON. But in conventional software testing, each test will be executed for each prompt only once. But in our case, we will actually have each test executed multiple times. Is it what you are saying?
Yes. And then we're gonna take, like, depending on the metric we're talking about, like we're gonna take the average of whatever the right thing in that situation is. Yeah. So we went through the first iteration with the researcher evaluation, and now we can actually look at what that evaluation produced. Let me show you. Okay, I have to. Yep, that's the one, the local. So this is the report of evaluation, right? And these are our metrics: final response match, the quality, tool use quality, etc., trajectory recall. And you could see, if you notice on the screen, that everything was great, obviously, because that's a heavy path, that's a demo, and surprisingly it worked this time. But you can see how the agent actually sort of like explains like why the LLM thinks that it's all good, right? So the final response match, it essentially says that it matches the expected response, like I would say enough. So it's obviously never the same, but it matches it enough to say that, yeah, it matches. And then response quality is good because it provides sort of like the information that the user asked for in the form that it asked it for. And then the tool use quality, we call the tools that we expected, and the trajectory precision, there is no explanation because it's calculated by Python code. And then for
it
the
is
second,
deterministic, right?
yes. Meanwhile, my hallucination check also passed, and I really want to show you that because it's
Oh my
not
God.
100%.
It is not usual, I believe, with deterministic or with hallucination, right?
Hallucination, it's a very heavy metric because the answers are big and it's a lot to check. So let's look at that one. And you can see that it's not 1.0. What's the result? Let me look. Yeah, it's like 0.82, right? So something like the model actually hallucinated a few things, but kind of in the acceptable manner. So we see that, for example, there is a failure. Hopefully you see it. Like, let me increase it even.
Yes, I can see, but I think we can
Yeah.
zoom in. Can you expand and see what is the rationale behind it?
Yeah. So you can see that the engine answered that early defenses that were like raw subdued neighboring tribes, and then the context basically that what Wikipedia provided is that it actually happened in a different year, right? And the model was able to spot it and say, okay, that's effectively a lie. Like you messed up the dates. This one, like the Punic War, Rome built its first major navy and seized Sicily, Sardinia, and Corsica, right? And then the label unsupported means that we actually do not have data for some of the statement, right? Um, Again, this may be true because the model knows about history of Rome, obviously, right? It was trained on a ton of data, way more than Wikipedia has. But what's important here is that it must be grounded to the data that we provided initially. So if we talk about, like I mentioned, if we talk about legal stuff, right? The laws, they change all the time, even though the model was trained on some version of a law. The law may have changed, and we should make sure that the data that we returned, in our law library was used and not the old data that the model was trained on.
It is a very good point. Do you think that we can zoom in into this custom call function execution and look in it closely? Because some of the standard criteria can be used or not used depending on the flow, but the power of introducing our own tests, especially when we speak about testing some integration or some more deterministic scenarios that we want to enforce in our agent, can be very useful, I believe, to many people who watch us.
Yeah. So that's kind of how we evaluate agents. Um, I'd like to briefly talk about using this flow as part of CI/CD pipeline with Cloud Run, which is also part of our lab, our code lab.
Okay.
So essentially, like if we look, what am I projecting now? Projecting.
Collab.
Yes. Yeah, I'm gonna project my anti-gravity window again. So as part of our checks, if you look at the kind of deploy script, that it deploys everything to Cloud Run, deploys all the agents in our multi-agent system. They integrate using A2A protocol, interact using A2A protocol. So the root agent talks to other agent using A2A, and each agent is deployed individually. Obviously, for this toy example, that may feel like overkill for you, but for the real agent, that's how you want to do it. And our deployment script, they actually use the approach called kind of shadow deployment, which Cloud Run supports, where you can deploy your service with the so-called revision tag. And in this case, I used my git commit as a revision tag, right? And that revision will be a full-blown Cloud Run service in Cloud Run, and you can call it. It has a like HTTPS endpoint, etc. But it's not serving traffic to the regular users, so the users don't actually see it. It's only your system, the CI/CD system, that knows that this revision exists, right? It has its own URL. Let me show you.
I want to just to clarify, Vlad, because I hear you using a new revision and new service more or less in the same sentence. So when you use it, what actually get created? A new service?
A new service is not created. Let me show you quickly, which actually makes a lot of sense. I'll show you how it may look.
Okay, while Vlad is going through the code, I want to share with our watchers, if you never used Cloud Run, it is a serverless platform that allows you quickly and effectively deploy a workload as a service. It runs fully managed in the fully managed environment on Google Cloud, so you don't have to care about scaling problem, about allocating resources and other stuff. And I believe what Vlad is trying to demonstrate is how the service will look like when we deploy a revision in the shadow mode. So multiple revisions, practically speaking, allow us to manage different versions of the same service. And usually we have one main like version or revision in the production that gets all traffic.
So here's the all my revisions. Every time you deploy, like redeploy a service in Cloud Run, it creates a new revision, right? And revision may have a tag, may not have a tag. All my revisions are tagged. And by default, when you deploy a new revision, if you don't specify additional parameters with the deployment, it's going to start serving traffic, right? So it has 100% traffic served, and you can see that my February revision serves the traffic. When I deploy a tagged revision without switching the traffic, it's getting its own URL. You see like the little pop-up with the URL that is named after revision tag, and then it has like this little like three I don't know how to say it, like the three dashes, and then the regular address. So this is where my private revision is accessible through, right? That's its individual URL. So it's not, when I go to this default URL of my Cloud Run service, it's going to serve the revision that currently serves the traffic. Like the Cloud Run can actually split traffic between the revisions, so you can do A/B testing, etc. But for us, it's important to deploy this shadow revision, test it fully, and if tests are passed, then we can switch the traffic, right? We can click manage traffic and say what is the revision that I want to serve traffic through. So we deploy it, it's for real, it's real service. We can do all the integration testing with all the agents involved. Once it's good, we say, okay, this agent is ready because it passed the test. Let's switch the traffic and redirect our users to this new improved, presumably, agent.
So we test on a real production environment without the risk exposing users to the untested version, right?
Yep.
I just want to add from the security point, there is no actual additional security introduced for this case. So if someone knows this URL, and as you saw, the URL is kind of generated using some signature or
it's actually
digest.
the commit hash from Git. Short hash.
Yes. So if someone knows it, this service can be accessed. So it's a certain level of vulnerability is present, but it is relatively low because, again, we expect that without getting access to the internal infrastructure, it is very hard to guess. And it is these revisions are usually very short-lived. And additionally, another good practice is to create a staging environment which reproduce the production environment like 100% from all ways, except for maybe the access from some external from the public locations, and then you can cover this additional topic. Sorry for like hijacking the stream from the testing
that's
to
totally
the security
fine.
part, but it is, yes, it is a kind of thing that important to remember when you utilize shadow revisions. Okay, let's move forward. We are about 20 minutes before the end of the broadcast, and we want to cover and address questions that were asked. I see we have quite a few questions. So let's move forward with
Just one
is
more
left.
note before we sort of move to questions. A lot of people ask, like, how do you come up with those test prompts, whether you have reference for them or not? And that's like one of the most frequent asked question. And the answer for this is that you effectively need to collect your what we call critical user journeys, or happy paths, or golden paths, like the questions that you really want to work with your agent. And the way you collect it, like there are multiple ways. Like obviously, some of it you just write them down. Some of it you have your early testers. You see what they ask the agent and what answers they expect. You use feedback. If you have a feedback loop, those like, dislike things that you can say, oh, the agent was wrong, or I don't like the answer. That's also how you collect it. And finally, I mean, you can use another LLM to create those, because that synthetic data is always helpful in those AI workflows.
It reminds me a bit how we explain discovering critical user journeys with SRE, site reliability engineering.
Yeah.
We actually say the same thing. So you discover it from the previous data that is already existing in the system. If you don't have it, you go to your business logic. There are some kind of designs or functional requirements that get fulfilled, or you just invent it in the case that nothing like this exists. And here we can use and utilize AI. I just wanted to add also that you usually don't have to care about different formats or different ways to ask the same request, because as we mentioned, the model-based grader uses a strong AI model. So defining a relatively straightforward prompt will cover all other ways that people can come with, or another application can come with, send the same request, because it analyzes the semantic meaning as opposite to the just matching or comparison.
All right, we move to the questions, and the first question is from Brian from LinkedIn. The question is, in a multi-agent evaluation pipeline, what parts of the agent process are treated as observable? Whether it's final response, tool calls, agent-to-agent messages, planner state, memory reads and writes, routing decision, or execution traces? That is a very good question. So ultimately, with frameworks like ADK, and especially on Google Cloud, everything is observable, right? So you can collect the intermediate steps. It's depending on how you call your sub-agents, it may be harder or easier to retrieve, but ultimately everything is available, everything is traced, and it's better than if you provide it to your graders, whether are deterministic or not, as a whole. However, there are always caveats, right? If you create like a proper sub-agent with calling sub-agent as tools and not necessarily with delegation, then whatever happened in the sub-agent may be hidden from you. This is why it is important to evaluate your agents at every sort of like at the highest granularity possible, right? So you can see that we evaluate researcher individually, and we should be evaluating every other agent as well, right? So judge needs to be evaluated too. right? And then we evaluate system as a whole, right? And if we have those subsystems like sub-agents that have other sub-agents, you need to evaluate those too. Just like with your software, right? You have different components, and then you have components integrated to bigger systems, and then you have individual functions, right? If you want a good test coverage and the right test coverage in your system, you do it at the very at every single level, and that's the best practice, and that sort of saves you from things that happen to be hidden, right? Like we don't always have the entire trace, um, not necessarily saved. Like we usually have it saved in the tracing, and this is something that you can see this lab also demonstrates how you collect traces along the way. But when you submit it to the evaluation service, not every single call may be visible. So that's why you want to do it at different levels of granularity. Anything that you want to add to it, Leonid?
No, I feel you covered. I depending what the question mean, because I feel there are a couple of interpretation, but basically we want to go to the observable information for this particular agent. So if this agent invokes tools remotely, or it invokes other agents as part of the flow, we don't want to observe it as testing this particular agent, simply because, again, we are testing user journey for this agent. But I completely agree. In general, we want each component, each agent, to have its own set of tests for its own critical user journeys.
One more question from LinkedIn. How would you design a continuous evaluation pipeline for a multi-agent Gemini system that can automatically distinguish whether a production failure was caused by the LLM, agent orchestration, tool execution, retrieval, or prompt design, and continuously improve the system without introducing evaluation bias? That question has actually a lot of questions in it, so I'll try to give to do my best answering it. So the way you distinguish what introduced the issue is that you need to look at that interpretation. Remember how we looked at the report, and the grader was essentially explaining like what happened, like why certain piece is not right. It's like providing rational for that part. So you need to look at that part and maybe even use another LLM to classify what component introduced the problem, whether the tool returned something wrong or the tool information was right, or sorry, the tool returned what it was asked for, but the query was wrong. For example, I did an experiment yesterday. I added the to the prompt of the researcher a sentence: replace Rome with Berlin. Like whatever result you get from Wikipedia, just replace it, right? And the LLM grader was able to say, it's like, oh, because the agent was actually instructed to replace all Rome with Berlin, the LLM ended up asking the tool for a wrong city, not the one that the user asked for, right? So that sort of classification they were able to pick. And this is something that you can also analyze and effectively do it, like create a little classifier that says what component introduced the problem. So that's, I think, the best way. So we keep layering LLMs on top of other LLMs, but that's essentially the reality of this non-deterministic world, that we rely on LLMs a lot. And like we mentioned previously, the way you mitigate this risk potential is that you do it many times, right? You just run the same prompt multiple times and see what essentially was produced and what was the reason something failed. Sometimes failures are, I wouldn't say deterministic entirely. Sometimes failures are not LLM related. It's just like, oh, you made the query to database and there was a glitch and it came with an empty answer. Those you should be able to spot. Just like, okay, tool call failed because it came back empty.
I just wanted to add also that I believe we can, in many cases, separate the problem of evaluation, detecting the problem due to the changes from the analysis, because I feel that this question is more on analysis why a specific test fails, and not to detect the failure itself. So analysis, we will usually implement some to automate it. Again, we can employ various agents that specialize on analysis of the code changes, and we can stream the information from the evaluation that comes, as far as I know, and Vlad, correct me if I'm wrong, it is not formalized currently. There's no like common standard for evaluating models across the companies, across platforms. And the agent platform uses their own format for returning the results, but we can obviously teach agent about the format and provide it as additional input and automate the full like pipeline. However, it is a bit outside of the scope of the evaluating.
Yeah, you're right. It's like you run unit tests. Let's think about traditional software. They fail, right? And then as a developer, you kind of go back to this exploration mode, experimentation mode, and start analyzing why did it fail, right? So you can have some tools that help you with that, but that's not part of the defense system. The job of the defense system is to not let your bad agent to production. One more question. In production multi-agent system, how do you recommend balancing automated evaluation metrics like tool use quality, trajectory precision, and hallucination detection with human review? At what point should a team trust the evaluation pipeline enough to promote a new agent revision to production? There's no like right answer to this question. The question itself obviously states like a very important reality is that people need to be involved, right? And the more people you have reviewing those results, the better. And yeah, we should have people looking at it. But I think the most important part of where people are needed is when you create those golden data sets, right? Those test questions with, if you have references, like with the reference answers, you have to look whether those answers actually valid for the question. This is where you can see that the reference is actually right, because I often like talking to different customers of Google. We often see that that data is collected, so the question and then the answer, and then turns out that the answer is actually wrong or only partially right, and some human at some point came up with this answer, and now we use this reference answer to decide whether LLM was right, but the answer turns out to be wrong. And then the test fails, and everyone is upset because they think that the agent is not working, but in fact, yeah, it was just the human wasn't right with the answer. That happens all the time, and LLM in this case, they're actually able to catch the human mistake. But when obviously how we learn it, oh, we look at this failure and we see what failed, and then a human reads it more carefully and realizes, ooh, it turns out to be wrong. And many customers, they actually can, they use LLMs to, again, to judge those failures. But this is, again, that's not part of the defense system. We move back to the experimentation mode, but this is important. You can employ LLMs to explain why the answer is wrong, why, like what this is our reference answer and why it doesn't necessarily match. And then LLM may tell you, oh, you know what, the reference answer is wrong. So that's how we do this. I think that's kind of the time that we have. I'm sorry that we didn't answer all the questions that were asked. Feel free to reach out to us on LinkedIn or X and other means. We'll be happy to answer more questions. Any final words, Leonid, that you want to share with people? Just, recommendations.
So the most important is always evaluate AI agents. Don't believe that it will work just because you use a strong model or you tested it manually at some point before production. This test, the lab shows how to test as part of the continuous integration and deployment pipeline, but you can employ some of this testing just on production itself, the same way like some synthetic tests get run on the production environments to track that things don't steer. Because again, like we mentioned, agents utilize not only the model, but tools, and tools are based on the real-time data, which changes. So your test could be fine at deployment time, and in a week or months, depending on your release cadence, it can behave strange, it can drift. And another thing, at least what I'm continue telling to myself first and to others as well, the fact that it is AI doesn't invalidate your knowledge about how you test things, how you build tests. You do have to build the test harness. You obviously will have to enhance the existing test harness, but it is the same methodology, it is the same logic. You will just have to learn a couple of new terms and new methods. Part of them we showed, and I hope it was helpful. And if you have questions, please find us again, Reddit, LinkedIn, Hacker News maybe. We sometimes announce there as well. Vlad?
Yeah. Thank you so much, Leonid, for being here with me today. I hope the audience liked what we presented and will be able to use it in their day-to-day development. Create your agents, evaluate them, always evaluate your agents, use Google Cloud to deploy them and run at scale, and go try the lab, deploy it yourself, evaluate and see how it works for you. And thank you so much.
I forgot to mention, next month we will be broadcasting live another episode that will be focused on protection of the models. So please keep tracking the announcement and join us next month. Thank you
so much, and have fun.